Welcome everybody today. Thanks for taking a few moments of your time to listen and allow us to share a little bit about Akanda. So a little bit about me real quick. My name is Mark Klein. I am the CTO of Akanda. I'm also a member of the OpenStack technical committee. I was former Neutron PTL during the Havana and Icehouse cycles. Also, as far as the Akanda project goes, I was one of the original lead developers on the project. So, just a little background into what Akanda is. Akanda is a 100% open source project. It's Apache 2 licensed. We originally kicked it off when I was at DreamHost in 2012 because what we were looking for is we needed a solution that integrated well with OpenStack, allowed us to deploy IPv6 into an OpenStack deployment, and it was able to be used by thousands of VMs daily. So that project grew within DreamHost over a couple of years, and then in October 2014, last fall, DreamHost decided to follow the same similar path that they had with Inktank and Ceph and spin out Akanda into a separate entity. So at the summit at the OpenStack summit in Paris last November, we announced the spin out, and at the upcoming summit in Vancouver this May is when we'll have our first 1.0 release, and basically what that's going to, and we'll share a little bit more details about that as this goes on. So it's kind of level set a little bit. There's several use cases, making sure there's for change, ensuring that we're providing for cloud service providers, the enterprise private cloud. Some of these use cases, when you start talking about service providers and enterprise private clouds, look exactly the same. Sometimes they're very different. Some enterprise private clouds are actually bigger than service provider clouds. So having that agility is very important. And so that was one of the use cases we were trying to solve, as well as also improve multi-tenant security and compliance. When you start talking about microsegmentation or segmenting apps, you want to have that agility, as well as enforcing policy. A couple of things also as well is that deployers are really concerned about making sure components run on standard hardware. And the hypervisor they get to choose. Having an open platform without lock-in, one of the difficulties with many of the solutions is that sometimes that once you select a platform, you're stuck on it, and that the pain of switching in many cases either requires an entire reboot of your cloud or a very painful migration process, as well as ensuring higher security, compliance, reduced time, deployments, as well as reducing capex and opex. So when we take a look at what's available today, generally you have, there's a lot of interest in NFV space where you have deploying and exposing the network functions. Some of them are very vendor specific. Some of the standards are still being and some of the conventions are still being developed as we speak. We take a look at the OpenStack development. OpenStack is an interesting community. It's a very vibrant community. You have lots of participants in there, so you end up with an interesting scenario where you have lots of cooks in the kitchen, which sometimes slows down development because the consensus process, which OpenStack runs on, is designed to run slow at times. Mainly, it's to ensure that we actually do have consensus that the best selections are made, but at the same time, it's a little bit of a challenge because you have different vendors who are leading the communities and trying to get consensus. It's an ongoing conversation, as well as some of the SDN offerings that you have. Sometimes they're very complex. Some of them provide better visibility than others. Also, some of them, it's once you choose that offering, that's the only offering you can run, and it's really hard to integrate other solutions. So when you take a look at it, you have kind of that lock in a single vendor. Some of the SDN offerings don't integrate well with, say, white box or commodity hardware. Some do, some don't, but it varies a lot, and so it can limit as a deployer what your choices of hardware are, because sometimes you have to pick a SDN solution and the hardware that goes with it, as well as some of the options are very proprietary based, and so once you deploy them with an OpenStack, again, you're kind of tasked with only running that, and the common management platform is missing in terms of how do you deploy a fleet of these things? How would you expose a function? So when we start talking about Akanda, how do we fix that? We have three things we really want to emphasize, which is we want to make it simple. We want to reduce complexity within OpenStack. Neutron, as in the reference architecture, as a constellation of microservices, which in terms of management can be very difficult. That some deployers, especially as you're building out it takes a little bit of time to understand what all the microservices do, how they interact. Sometimes it's not always known how they interact or apparent at first, and so that's been one of the struggles in the community. Making sure that Akanda is compatible with different layer 2 implementations. One of the things we wanted to do was empower deployers to make choices and not dictate them for them. And the last thing is kind of a founding principle of Akanda, and something that we inherited from DreamHost, is a very strong belief in open source. Akanda was founded as an open source project, and we want to contribute and we want to continue to deliver as an open source project. We want to have all the source code available, no hidden gotchas in there. So as far as what is Akanda, the core components are really just the cloud network. It's orchestration. It's what orchestrates, and we provide network services via VMs. And so typical services that we're able to offer are routing, load balancing, firewall, VPN. One of the things that we have is Akanda, because of the way the orchestration layer works, is we can actually support third-party network services. So while we have open source components, sometimes deployers have or have chosen or have existing relationships with proprietary vendors. We're able to support those. We're also able to deploy Akanda over multiple different layer 2 implementations in terms of overlays. And Akanda interfaces with the vanilla OpenStack APIs for Neutron, Nova, and Ceilometer. And we're working on having integration in with Horizon as well. So when we take a look at what the architecture supports, kind of if you take a look at the typical stack, you have the Akanda management platform on the side. At the base, you have the physical layer 2 network within the data center. Akanda then interacts with any layer 2 overlay support that the deployer wants to choose. So whether you have like open source versions based on OVS or Linux Bridge, which are managing VLAN, VXLAN, or GRE, we support all those, as well as you can run Akanda on top of, say, another proprietary solution as well. On top of that, you find your typical OpenStack APIs for Nova and Neutron for orchestrating for tenant orchestration networks, orchestration of VMs. And on top of that, then you would find the Akanda managed services for routing, load balancing, and firewalls. So typically the services you would find in layers 3 through 7 of the network. If we're to take a look at a prototypical deployment of OpenStack without Akanda, you'll see this is kind of the canonical use case with the reference implementation. You have a relational database which is used by the Neutron server. The Neutron server then talks to a message queue to talk to a constellation of agents. Agents specifically dedicated for layer 2, for layer 3, a DHCP agent, and then like it says advanced agents, so that would be like load balancing, firewall as a service, VPN as a service, or even metadata services. When we add Akanda into the mix, what we're able to do is remove a lot of those extra agents. And so now you have one service which is managing layer 3, is also able to orchestrate load balancing, VPN. And so typically what you'll find is Akanda is able to manage DHCP layer 3 routing and load balancing, significantly reducing the number of components that the deployer has to deploy, the number of components you have to monitor, a number of components that you have to manage. So kind of circling back to the architecture we talked a little bit about before, if you noticed, we have the managed services of routing, load balancing. If we really dive into how's Akanda managing those, Akanda really takes care of, since we're combining some of the services, it's going to take care of some of the critical functions such as health monitoring, event processing, also dealing with the interactions from Neutron. So when a tenant interacts with Neutron, they're going to be using they're going to be manipulating the logical instances, but not necessarily the actual realized instances. So what we're able to do is take the event stream from Neutron, drop that into the event processing queue, and then the Akanda orchestrator, which is a multi-process, multi-threaded worker, is able to then distribute that out to individual workers, which then manage the life cycle of a VM. What that does is, a lot of times it's very easy for those who have experience with OpenStack. It's very easy to launch a VM inside of Nova. The difficulty is actually keeping the VM alive, monitoring it, ensuring it's healthy and running. And so what we're able to do is Akanda orchestrator takes care of all those tasks for you and is able to report back, is able is able to receive notifications and then make intelligent decisions based on that. So if there needs to be update to the instantiated configuration, Akanda can take care of that. Within the workers, though, if you kind of dive into it, so if we kind of dive in a little bit deeper, the workers are really a combination of three things. There's a state machine which keeps track of the entire life cycle of the VM. There's a component which takes care of managing the VM. And so that just from the Nova perspective of ensuring the VM is up, running, if any interfaces need to be hot plugged or removed. And then lastly, there's a driver. And the reason we include the driver is the driver allows us to support multiple network applications within Akanda. So the driver also allows us to support different images as well. So if we have open source images, the driver knows how to talk and interface with the open images we release. If there was a proprietary third-party version that the deployer wants to deploy, by writing a very small driver layer, you can still benefit from the same lifecycle management, the same monitoring and notification services. All you have to do is really integrate with how do you render the logical configuration onto the service instance, and that's primarily what the driver takes care of. So when we talk about what's coming in May, we're going to have our first OpenStack Kilo compatible release. One of the things is that anytime you spend something out, Akanda originally started out as an internal project, and so you remove the project from its nest. And so what we've been spending the last couple of weeks on is ensuring that Akanda is compatible with Kilo, as well as supporting features that you would find, such as having the ability to have routing pairs so that you have high availability for routing, as well as supporting load balancing. We'll have support out of the gate for HA proxy. There's also some other support in flight for other higher end layer 7 load balancers, ensuring that it works across a wide range of layer 2 of layer 2 technologies. And additionally, adding service management capabilities. The service management capabilities we've had internally since day one, and so we have tooling designed for operators for daily management. I think one of the tricky things about when designing some of the tooling is that sometimes what necessarily is good for sales and marketing, the operators don't always like. So one of the things we took and have really made a conscious effort to make sure that we have tooling that actually supports and empowers the operators to manage real easily and effectively. And so via the Conda orchestration, that's all set up. So, it's kind of the overview, kind of the introduction into Akanda. And so, really our code, like we said, all of our code's available on GitHub. It's available github.com/Akanda. We have an IRC channel where we hang out, as well as, we're available via Twitter. So at this time, I'd like to open up if there's any questions.
All right, Mark, I don't see any questions at this point, so why don't we wrap it up?
Alrighty. Well, I thank you all for taking some time out of your day to allow us to share a little bit about Akanda. Remember, please check out Akanda.io, have information about what we're working on, as well as feel free reach out to us via our community in GitHub.